So this next example, we're told to write the equation in logarithmic form. Now, here's where I want to show you how to go through this problem in what's a method that will help you later. Because one way that you could go through this problem would be to just look back at our definition of the logarithm and try to play a matching game and say, let me figure out what the b is, what the x is, what the y is, and just plug it into this definition over here. And while we could definitely do that, that's not going to be helpful. And these are a second version of what I'd earlier called jumping jack problems, where the whole point of these problems is the process, it's not the answer. Because if we look at what we're starting with, we're not solving anything. We're given a completely true statement. 9 cubed really is 729. There is no ifs, ands, or buts about it. It's a true statement. So we're not solving anything. We're just trying to rewrite this with a logarithm involved. So the point of this problem is actually to work out how do logarithms work, to figure this out and to get a feel for it. So what I'm going to do first is I'm actually going to rewrite this with a little bit of space in here. We'll put a little bar here so we can separate each of these examples. If I want to introduce a logarithm, the logarithm is meant to undo the exponential. So I got to look at the exponential that's in this problem. The exponential is that I have 9 raised to a power. That means the base of the exponential that's in the problem is 9. So if I want to introduce a logarithm into this problem, the logarithm that makes the most sense to introduce is a base 9 logarithm. So what I'd like to do if I'm going to introduce a logarithm into this problem is I want to undo the base 9 exponential by applying a log base 9 logarithm to both sides. Now it's important that we're putting this on the left because we're plugging 9 cubed into the logarithm. We're plugging 729 into the logarithm. So we're taking log base 9 of both sides. Now as we write this logarithm, I want to point out that the log and the 9 cubed are on the same level, the same line. Like if you had line paper here, they would be right on the same line. The base 9 to the logarithm is written a little bit lower than that. That's how we know that this is a base 9 logarithm. It's written a little bit low. It's what we call a subscript. Now, back to this problem. Now we can simplify this a little bit. Because now I have log base 9 of 9 to a power. Those things undo each other, leaving just the 3. Now on this other side, I'm happy leaving it the way that it is because my goal of this problem was to turn this into a logarithmic equation, which now we have. So our goal is to get a logarithmic equation from an exponential. Let's undo the exponential by applying the appropriate logarithm. So moving on to the second part of this example, I'm again going to leave myself space to write the logarithm. Now as far as which logarithm to write, I look at what the base of the exponential is. Because that's how we're going to undo the exponential, is take the log of the same base. The base of my exponential is 6. So I'm going to take a base 6 exponential, or sorry, a base 6 logarithm of both sides. Now again, when I'm writing these logs, the log and the argument are on the same level, on the same line. The base of my logarithm is a little bit lower, so make sure we're writing this correctly. And the way that this is read is log base 6 of 6 to the negative 2. So, back to this problem. My log base 6 and my 6 to a power undo each other, leaving negative 2 equals log base 6 of 1 over 36. And that's the equation that I want for an answer. Now we can hopefully move a little bit faster through this last one. We have 5 to the 1/3 equaling the cube root of 5. The exponential in this problem is the 5 to the 1/3 power, meaning the base of that exponential is base 5. So that means I take a base 5 logarithm of both sides. Again, the log and the argument are on the same line. The base is a little bit lower. The log base 5 and the 5 to a power undo one another, leaving the 1/3, and the right-hand side just stays put. And that's what we're looking for when we want to take an exponential equation and rewrite it as a logarithmic equation.